to save streaming. I think right now I'm going to try to figure out this process here, creating the dictionary with the frequencies of hands, and then saving a bunch of files with those dictionaries, and then figuring out a way to save the simulations based on the dictionaries, and then try to create something that reverse engineers the algorithms of transforming the dictionary into the format that is needed for creating the simulation. I was thinking about using a convolutional neural network for that, but I think it's not necessary. And the problem with using the machine learning approach is that I'm gonna have to rely on the model then. Because the way that it works is you build a model. If I can manufacture the data, obviously I can overfit and it's not a problem. So it would be easy, I think, if I have enough data to just train a convolutional neural net based on sklearn libraries. I would have to search some stuff around, but then I think once I have the model, is not that hard, probably. But then the issue is that I rely on the model to create the ranges. I don't want that. And I think I don't need to resort to that, because there's probably a way. I'm gonna have to think about it now, how to do it. But I'm gonna create samples, and so the first thing that I need to figure out is how to save these simulations, because just looking at the outputs here, it doesn't show anything to save. When I click save here, it doesn't show anything here. So I created the standard things. The other thing that I did since last time is that I also realized that it's better for me to select some batch sizes that I think I will use, or not necessarily, because the purpose of doing this is not so much to play better poker for me. It's more to become better at software engineering, because that's my main priority. So this is also like a kind of disclaimer. I don't think that I'm not really sure. It might be the case that it helps me a lot to improve, but I don't really know for sure. And it might be just a waste of time when it comes to poker. But my main priority here is to just become better at software engineering. And I thought that this is a good project because I kill two birds with one stone. Because I do play poker and I make money from poker, but I know that I can play a lot better than I'm playing now. So at the same time that I increase my chances of improving at poker, I become better at software engineering by doing this thing. So that's why I'm doing. But then I realized that it's probably better for me to put the batch sizes that I got from the data on one side of the situation. So when I'm out of position, I leave the batch sizes that I got from the data in position. And then when I'm in position, I get the other way around. And the other thing that I did here was multiply by 100, because this thing doesn't allow broken numbers. So I multiplied by 100 to get the effective stack and the starting pot size. So what I'm gonna do is just get these files here that I have, and I'm gonna copy the instructions from them. And I think I'm gonna create a script that opens the file and reads the file line by line, and then executes the solver commands through the file. And then I'm gonna experiment, because I think that I can just I wanna see if the last command returns the whole script, so I can save, like, what is the equivalent of clicking here and going full save. I want to pretty much automate this. That's the most important, or not this actually, to automate this button here. Maybe, yeah, I don't know if this is gonna be possible or not. Hopefully it is. Maybe I will read the documentation as well now to see if it is. I think I'm gonna put some music for me and leave without music the string. But what I was thinking about doing, so there's two main things that I need to do. One is this script here, and the other is create the tree. I was thinking about creating a tree structure of the node IDs, but then I realized that it might not be the best, because the tree would get massive. So I was thinking about doing something like this. But then for each hand, I would have to create a flop. Then the flop, I get the decisions that are possible based on the bets I have. And then from the bats, I create the other bats, and then each branch here would have to go to the turn, which would have 13 possibilities, or not 13 actually, it would be 13 minus 3 from the flop. It actually would be a lot more because there's suits as well. So it would be close to 40, I think it would be 49 combinations for each single decision on the turn. And then each one of those decisions would have a bunch of other decisions, so it gets pretty massive for every hand. And obviously that's what's happening here when you create the simulation as well. But the thing is that I think from the data standpoint, it's not the best. It's probably better to get all the frequencies that I have on the data and then use that frequency to build the trees after. Because that way I think is more optimized. And then I thought about it, and I think it might not be even necessary to create this, because the structure of the node is like a string here. That's, you can see, and they talk about it in the documentation. So I think I can do, like, I can format the string based on the line, the sequence of the line and the actions. And I can do that based on this function that I created on the simulation class. But I think I'll do that later because I want to focus on one problem at a time, otherwise I'm going to be confused. So here I'm thinking about using ChatGPT to get all the possible combinations of suits and cards and ranks to get all of the combos that exist. And then I need to get all possible combinations of 2 different cards together to get the pocket cards. And that's going to be the range. And then I'll save in a file, I think. So I think I'm going to copy from the other scripts that I did. I think it's the range one. To save on the file. Obviously, erase the stuff that I'm not going to use. Here, I'm probably going to create I am going to create a different file, different folder. I'm gonna put whatever name, just so I don't spend too much time thinking about this. I'm gonna follow save on this thing here. And what name I will give. I think the name has to be dependent on something because I'm gonna loop over. Yeah, it has to be. I'm gonna do a loop here. Where hands. Oh, actually no, because the dictionary is gonna be one combination. Actually, yeah, one combination. So the hand range is gonna be a template, and then I create something that randomizes the frequencies to create a bunch of different samples, and then save each sample in the file, so that I can use the sample to create the other files that are gonna contain the logic here, like this part here. And then the function that I want to create is input as an argument the dictionary and output the matrix of these numbers here. So I can convert the range from the dictionary to this format here to automate the process of running those lines. Maybe I should create the script to run the stuff first. At first I have to think about how I'm gonna do this thing here. Because I think it's easier to just ask ChatGPT. As I always forget how to. Obviously, I can look at the source code or the documentation. It's just easier to ask ChatGPT. diamonds, spades, clubs, and hearts, and the rings. Okay, so it uses the product instead of the combinations. I just copy this stuff. Then I'm gonna comment these out for now, and then once I have everything, then I will do the loop. And oh. Okay, so it returns tuples is not that what I want. All combos, I suspect that is gonna be hand 0. Gonna be hand 0. The tuple. And then I just put F for now, but I wanna join. I think it's the other way around. So I need to join based on the pattern. So I confuse the two because of JavaScript. And then I print off here. Yeah, so it does return, but it's returning. So this is wrong. As obviously they're all repeated. Maybe I should just ask ChatGPT. Maybe there's a better way to get the combinations of 2 different cards as well. I was thinking about doing 2 for loops and then just getting the combinations. And for each one of these, I just add and then append to a list. And then from that list, I create the combinations. And this is trash, I think. For each tuple, we concatenate the rank. So it's fun. Maybe it's better to do the 2 combos that I think about. Oh, I'm doing the other way? No. I just copied this from ChatGPT. Let me try the nested for loop. I don't know if that's gonna work. Yeah, there we go, but it's the other way around. So obviously, let's do like this. It doesn't matter that much, the speed and everything like that. Don't care about that. We're just gonna use this for creating the tasks, so it doesn't really matter. Given a list like this, what would be the best way to get all possible combinations of cards in these formats? Oh, do I have all of them here? Yeah, I think I do. This hearts, yeah, I think I do. Diamonds, spades, hearts. So I think it works. Just double checking, but I think this is correct. It's the king of clubs. It becomes massive because then there's a lot of different combinations between all these possible cards here. And now I use Ether Tools. Hmm. So I did the same thing I did, but in a list comprehension there. I don't feel like thinking, so I'm just gonna do that. Nice, this. Not what I want. Yeah, there we go. Nice. Okay, so now I have this. I think I can use dictionary to transform. Let's see if this works. But I don't have the key. That's the problem. So instead of this list comprehension here, I can just transform in the dictionary here, maybe. Yeah, there we go. So that's what I want. But I don't want them on the list. That's the problem. I shouldn't do it like this then, I think. Because it's too confusing. It's just easier to put this stuff here. Oh, it's doubles. That's the problem. Yeah, so I need to change the combo first. Yeah, now it works. I just remove this stuff. Okay, so now I have all the ranges. So now let me think. Yeah, I want to create a loop and then append the different ranges through the loop. So first I need to think, because this is the part that is kind of tricky. Because depending on the way that I decide to put the frequencies of each hand, it might be easier to figure out the connection between them. Also have to, maybe it's a good idea to look at the documentation to see. Oh, also in these ranges here that I did, I had to delete a bunch of bat sizes because the size of this tree gets really massive. So I don't have enough RAM. I have, I think, 40 GB of RAM available. And then some of these trees, like if with all the bat sizes, it requires 80. And I think also like this amount of bats is probably too much also. Like if you're gonna do simulations to improve, because the more bat sizes, obviously the more likely that you're gonna make mistakes. So there's always the trade-off of how complex you want your strategy to be and how effectively you're gonna be able to implement. And because people were not robots, obviously, it becomes increasingly harder the more bat sizes you have. Maybe there's something else that I can do here with this stuff. Well, I think what I'm gonna do for now with the hands that I have, the data that I have, is just to create simulations from the river directly. The challenging part is that, yeah, I'm gonna have to use my data as well then, like as my range for the river. That's probably what I'm gonna end up doing, where I create the string of the nodes tree exactly from the hand that it was played, and then I get the hands that I have the most data, which are the ones that have the highest frequency, and then based on those situations, I get the based on that position, specific position versus position, and the lines don't matter that much, but they will matter because it's the river. So I think I need to, like with the data that I have now, it's probably better to just try to create simulations based on the stuff that I have the most data. So the stuff that happens most often, which is the ones that I have the most frequency. So I just get the specific node IDs based on the lines through the loop as I'm looping through the hands. And then from those spots, I get the frequencies which allow me to construct the range for myself and for the opponents. And then I construct the tree directly from the river with Pio instead of creating the flop and then I train on the simulations that I have. But then what I'm gonna do after that is to just, because I think I'm gonna redo everything based on the cards that based on the hand histories that have the whole cards exposed. Because obviously that way is gonna be much better. So I wanna create the system for that one now, because then all I have to do is just play a lot more hands, and then I'm gonna slowly over time build up the data again. So I wanna have everything ready so I can already start setting up the simulations based on the amount of data that I get. So I don't think it's worth a lot of time investing here into building the ones from the flop with the current data that I have. I think here is on configuration and then debugging. But I'm not sure if it's gonna show any extra stuff from commands and solver response, because I only think that it shows the commands on the tree there. It doesn't show the logs of the how to save the stuff. Because the only reason why I need this info is so that I can automate the process of getting the ranges and then saving the simulations, because all I care about is getting the file at the end. So I can create this whole algorithm there. And if I can't figure out, then I'm gonna have to do it manually, which is gonna be a pain in the ass to get enough, I think. It might be extremely difficult. And I want to see where this file is going to be. It's probably going to be here somewhere. Oh, here. So it's probably going to output there. This is the stuff that I did so far, I think. I want to put this stuff. I think I have to restart. Or maybe I can just click on the build tree and then on the go and then copy the commands. But it's, the thing is that for saving the current parameters, it doesn't matter the build tree or the go commands. If I click here, it doesn't show anything. Yeah, it doesn't show. Just let me think. Interesting. I just click copy and then I pasted here the information. So what I suspect is happening is that the solver gets these commands and then, but what command makes it output the rest of this stuff here? Because here the ranges are in the formats, the dictionary format. So, oh, I forgot that I'm using this file for the other stuff there. So how can I test this? There's a simple way to test what's gonna happen. You just copy. Just click here, copy this stuff. Test. And then I delete all of these parts here of deadline and this other stuff. There's some command, obviously, that the solver is doing to create all of this stuff based on the comments. And the stuff that it has there is the comments. So from this part down, the solver does. And then this is the stuff that is actually written here, I think. I want to know how the solver, what commands the solver uses to do that. Oh, it does work. Interesting. Huh. So maybe I don't need to. Maybe I don't need to convert. If I just put like this, I just format it like this, and then yeah. But then what command I'm gonna use to run? Oh, let's start to build trees. It's probably gonna work, I think. It just shows this stuff about the isomorphic thing. So it does work. So I think I don't need to convert. But the thing is that it might be necessary to convert for the node locking part. But I think it doesn't matter either, because like all that is happening is that the solver, I think, is the same. It works in the same way. So the only difference between node locking is like when you're node locking is like when you're navigating the tree here, and then you're selecting a range, but it's as if you're solving from this point here. So it is as if you had like this, and then you just copy the range, whatever range you have here, to here. But maybe it's different because of the bats. I think it's different. Let me think. Yeah, this is not solved, so the frequencies are messed up, but no, I think, yeah, how I'm gonna do this? I think it's different. I can't really, but the problem is how do I save the simulations with the solved results? Because the way that I think it works is I can get the range based on the data. So I solve from the flop, get the range from the data. Then I just figure out the commands through node lock, and then I put the range from the data based on the frequency of the lines that I have. But then how do I save those results to create simulations to play later? That's the challenge, I think. I guess that's is the same thing, but because when you solve the full tree, it solves with the current results, so it's probably the same thing. But I need to figure out how to save anyway. How, like, what mechanism here works for saving? Maybe there's something in the documentation. And drink some water. Let's ask ChatGPT, maybe it will give me an answer. What commands can I use to save simulation parameters from file solver using their universal open interface? And Python. Let's see if it's gonna say anything interesting. So here it just doesn't say anything. Redirects standard. This might be useful, but the problem is that I don't know the commands. Because I need the command to solve. It doesn't matter if I... Because there's nothing to append if I don't know how to start the process of solving. So it generates everything. And this is the stuff that I was looking at. Sure, this is gonna be useful, I think, later. I think I need... Oh, here. I think I need to focus first on the... Because I'm thinking about the second part. I need to focus first on this one. I'm thinking about this one. I need to focus on this and then solve this first. Because I think a lot. Load tree. Loads the tree from the contents. Oh, maybe in the example they have... Because they showed how to communicate. I'm gonna read this thing first. Saves current tree to disk. So that's command. So this is just save. So this is useful when I, like, after I run the simulations and then I do the no logs and stuff, then I can use this command here. Just save the tree for later. Yeah, but I think the example only shows this show metadata here. So yeah, it is useful because it was one of the questions that I had, but it doesn't answer the questions of how to activate this button here so that I save these text files. Just trying to see if he's gonna do anything in there. That's the other thing to think about, because I can use this stuff here. It's probably the scripting section there, because I can generate a bunch of jobs at once, I think. Yeah, I'll put the bars here, I think. But this, so I'll worry about this later. Yeah, I think you can just loop over the files once you have the simulations. I think the first step is to make everything so that it writes all the commands on a file like this, and then it loops over the directory with all the files, and then it creates this script here. On the example, they just show metadata. So then I don't think it's very useful. I don't think that's really useful, because I think that format's gonna expect. Maybe you should try to load tree, or choose one of these commands here. The one that saves tree. I think I'll copy in this file. I'll do copy here and do this file. And it's connection command. I think let me think about this. Yeah, so what I'm gonna do is use this file and the connection. So this connection command. I should probably put this stuff in the bottom there after the whole. Like here. Because I want to see if I can save this using the commands. That's the goal here. And then it prints lines based on the commands. So I'll copy this one. Put here. And copy the function. Oh, and it should be from the file. So I think it. Yeah, I can obviously open the file based on the directory there. I'm thinking whether or not that matters, because obviously I can write through the file, save the file before, then load the file and then use the load tree. I guess if it works, then it works, because the thing that I'm doing here is not the point is not to use this all the time. Is just so I can reverse engineer their algorithm to translate the range from this format into the format that they use there. But I'm not even sure if it's necessary. I think it is though, because of the node locks. I think that's the problem. Because this format here, even though it works there, I don't think it's gonna work when I want to do node lock. Because with the node lock, I think it's just you only use the range. See if there's any other stuff here that might be useful. But if I can load with the file and then save, then I think that it's gonna work, because then I can just change, like do all the lines the same and then just change one of the lines. Obviously, which is the last one that contains or whatever the line that contains the range. I think I need to kill the solver at the end as well. So I'm gonna open the file first. I don't have the file there. I'm gonna move this file here. So it's hand ranges. Yeah, hand ranges, then the name of the file, task file. Yeah, I think that it should be the path. So maybe it's not even necessary to do this. I just put the path here. I think it's probably the path and not the file object itself. This is also interesting. I think I can use the load tree in this one if the other commands don't work. And some additional commands. So it looks like it is gonna be, it's not that difficult to node lock. You just get the node ID and then use these commands here. And yep, the thing is, oh, so yeah, you pass the node ID, then space, then the range. So that's strategy in a given node for the ith child of a node. And the order returned by show children. Or returned by show children. Where is this show children? I think I've seen this command here somewhere. Show children here. And this might be an interesting one to figure out, these commands here, I think. Yeah, so I think these ones here are the key to figure out the order. So it's gonna be this 1326 floats, the order of the frequency, and then the actions are gonna be the another 1326 floats. Presents frequency of nth action with ith, and so it is a matrix of actions, obviously, because that's exactly how the GUI shows. The issue here is that it doesn't show. Like, I'm trying to think how to use these commands so I can learn how to what is the order of the frequency of the hands. But the thing is that I think with these commands it's probably not good, because it let me think more. Unless I can open a bunch of trees and then I just do this show range for a bunch of them, and I get the order that way, because that will allow me to. Yeah, but then how do I get the dictionary? I think it doesn't work, because it's the same problem then, but then like it's the reverse order. Like now I have the dictionary, and then I'm trying to figure out how to create the floats. If I do an algorithm like this, I would have the floats, but I wouldn't have the dictionary that are the equivalent for the nodes. Actually, I would based on the node ID, but I think it's too complicated just to get this connection between the two of them. Like you can select one node ID and then, or a random one, and then build the tree, then click on show range. Maybe that's a good way, but I think I'll leave this as a plan B. So create a random node ID. Then from that node ID, I construct the tree, and then I put this show range on another ID here. And then from that, I do a bunch of them. And because I know but it still doesn't allow me to know the dictionary. I think is not good enough. I think I was looking at this one. No. Yeah, I think there's nothing here that I can use to figure out how to save the file. Except these commands here. So build the tree from the file and then save. Maybe that's the best. So I think these here's are my best bet. Always retrieve from the content of the save file into memory. This is true. But I think this is expecting the CFR file, which is the file with the tree saved, is not the text file. That's the problem. And the build tree is gonna depend on the commands that were done before. And that's the issue, because then it defeats the whole point. Like, how do I get only from these commands to build in the tree? Well, let's try this one. It's dump tree. I think I don't need this. Just the... And then I call this print lines. But I think that this isn't correct, because I think it expects the CFR files. Saves current tree to disk, so I have to build the tree first. Yeah, so this is gonna be the file name that it gets as outputs. And then I use the builds tree from the text file that I did. Yeah, but the build tree, I don't think it receives any arguments. Maybe it's loads tree, but then again, it's gonna be the CFR. Yeah, I don't think through this I can. Try to find the load tree or the build tree. It doesn't receive any file names. Like, in my mind, the order has to matter, because how it would know like what combos are which? That's the whole problem. Hmm. Trying to think how I can do this, because obviously I want to avoid having to do it manually. But last resort, I'll do it manually, of creating each one and then changing the frequency of the ranges each time, saving a bunch of them and just getting the outputs here. But I think it's probably better to do that off stream if I'm gonna do that. So I'm trying to think about ways that I can, because the biggest issue here is that all of these things are not commands, they're just comments. So if I'm communicating with the solver directly, like, I can't reuse these things here. That's the problem. And so obviously I can open the file and then read through the lines and set each one as a command, but it's not going to work because it's not a command. So I'm trying to think if there's any way that I can figure out how it creates the commands from the comments here. Because obviously it's working here. If I just get the commands, it still understands. And then the only thing that could be is this build tree here. But I think that what this does is just the build tree thing. So that's why. I don't understand why they don't say anything on the documentation. The only thing that I can think about is that they might be concerned that people, because obviously if you know everything, then you can just reconstruct what they did here. So maybe they are concerned that people like break their thing or steal their stuff, their algorithms. And it's a fine line. I think that's the only thing that I can think about. the explanation why they wouldn't make it explicit. But then, like the thing that why this doesn't make sense is why make it available here then. That's what's confusing to me. Because if you're gonna make the ranges like the commands here and specify them, why not specify what is the format of the numbers? So maybe I'm missing something. Like that's what I'm trying to think about. Because it doesn't make any sense. Like I don't wanna just do the dictionary and then because even like do a random or an arbitrary conversion. So just create an simple algorithm that translates the dictionary into the sequence of floats without any concern for the order, because then obviously it can be incorrect. The main thing is the order of the numbers to build the ranges. So I guess I have to... Other thing I have to think about is if there's a command that is going to give you a return output so that I can save the return to a file. I can use the redirect thing to redirect the output into a file. So maybe, but to build the tree, I still need the ranges. That's a problem. Like it doesn't show anything. Because the biggest thing here is that the build tree is not connected to the save current parameters. And I want to know how this process works. I think I'll close this and open again, see if in the beginning there is any commands. It doesn't show anything. So let me think. Yeah, I think there's not gonna be a way. I'm gonna have to do this manually, probably. Oh, let me save the... I'm gonna create a bunch of these ranges and then save them to a file and see what happens when I open there. And because the ranges are gonna work for this thing here, but not for the lines, I think. Or maybe here. No, it doesn't show anything here. Oh, this one is interesting. Because if I can do it manually, but I can do it like this, then it's a lot easier, I think. There we go. There we go. So now I think it is a lot easier to do it manually this way. Because I was thinking about saving the current parameters, and then from the current parameters, I would have both ranges on this format. And I wanted to avoid doing manually because of that, because then it gets really difficult. But now I think I can save the files, and then I can just open the files from here and then convert them. And it's not gonna be, even though I'm doing manually, it's not gonna be that hard, because I can just do it like this. So it's a lot faster. I think I'm gonna do that. Yeah, it's not worth spending a lot more time thinking about how to automate this if I can just do it like this. Because it probably won't take a huge amount to figure out. Hopefully. Yeah, once I have the inputs and outputs, then I'll think about how I can use both of them to create an algorithm that is going to figure out the correct translation from one to the other. And then I can scratch this stuff. And then it's good that I read the documentation, because now I'm familiar with what commands I need to save the actual... The whole thing that I was thinking about here is that I think that these commands are not for text files. They are for CFR files, which are the formats of the solutions from Pio, which probably contains a lot of information about the trees and other stuff. So I can't just use these commands that are to save and to redirect to reverse engineer the thing, because the only way to create them is to have the ranges in the first place on the correct format. But once I have the ranges on the correct format, then it's good to know about these commands, because then I'm going to use them to save the simulations once they are done. And it doesn't look like the commands are that hard. I think if I spend some time, it's going to become easier and easier to figure out how to automate the process of creating these scripts. So I think that the part is not going to be that hard, or as hard as I thought it would be. I think the hardest part is figuring out the data structures, I think. Both from this part and the second part. I think the second part is going to be the hardest, because it involves also understanding what is the best way to create the simulations in a way that is going to allow me to see the best exploitation based on what Pio thinks. Like how to structure things in a way such that is Pio playing against the data, if that makes sense. I think that part is the one that is the hardest to figure out. Yeah, so here I'm gonna save. I'm gonna loop. So I have to think about how I'm gonna create. Let's go to ChatGPT. What is the best way to create random frequencies? It's probably gonna use a random library. I don't wanna look it up. It's easy to just ask ChatGPT, and then I'm gonna use a random. I'm gonna loop and use a random algorithm to create the frequencies of the hand ranges here. And then for each one, I'm gonna append them into a list, and then I'm gonna loop over the list, and I'm gonna save all of them into a file. And then once I have them, I'm gonna do this manually here, and I'm gonna save the dictionary, and then I'm gonna open another file, I think, for this. Or maybe I'll do it on this one. Just put the side by side, or yeah, the dictionary, and then this pattern here. And then I do this enough times, and then I think about a way to create an algorithm that's gonna figure out what is the correct position for each one. And then I could just use that to pass in the dictionary with the frequencies and output the matrix. I'll be right back. I'm back. Launcher creates random number in Python. Alright, there we go. Just gonna use this stuff. I think 30 is too much. Probably or 15. Oh, actually, now let me think about this. Oh yeah, I think it's. Oh, this has to go on nested thing here. Oh, for range or for and in and range. And I create this stuff. Or maybe I'll put this here. Yeah, so each one is gonna be there we go. And then here I have all hands and then append here. But the thing is that I need to create a new thing. Oh, but that's what I'm doing because I'm just. But the thing is, because I'm using Python, I think I can get away with this. But it's not good in terms of memory, I think. Because what I'm doing here is I'm passing the hand range to this thing here. But then I'm modifying that. So I don't know, like, because I don't know if the hand that is here is just gonna be a pointer to this hand range. So when I change the numbers here again, it's gonna change the other one. But I think it's not gonna do that. It's gonna be a clone. But I think in Rust it would give me a warning because as soon as it passes the thing here, then it's like it's dead. So I think that is not very effective. I think in terms of memory, doing things like this. Because what I want to do here is append the hand range there. And I think it might give me a problem. It might be a problem. I think it would be better. I think I'm going to do that. I just put this stuff here. Because that way I'm creating a different hand range each time. But I still think it's problematic because of the memory thing. But I think in Python it's fine. Yeah, create here, then append. Let's see if this works. I'm gonna comment this out. Yeah, I think it worked. Oh no, it didn't. There's an empty object on the other ones. So how can I do this? Oh, obviously I can also do it like this here. And just initialize there. So I don't need this loop. But you still have the problem where it's gonna be an empty dictionary on the other ones. And it's probably gonna be the same thing, so how can I do this? I think it's because of the combos. Maybe. Yeah, it's because it's just updating the same hand range all the time. It's not creating a new one. Or maybe it doesn't. It creates the new one because it is appending the empty objects there. So maybe it's because of the combo here. Now what if I did this? Thing is, even if it works, I still think it's not very good to do things like this. So now it seems like it's working, but I wonder if the numbers are the same though. So I think there's a way to check this. Yeah, it's the same numbers. Maybe there is a way to do a deep copy in Python. Because I want to create a new object each iteration, obviously, so I can append to the list. Yeah, I'm gonna try to do this. I just want to do it in the easiest way as possible that it works. so I don't have to spend a lot of time thinking about this. I just want to figure the algorithm out. And maybe I don't need to do this part here as well. Alright. I forgot that. Forgot that I'm using that to build the dictionary. Yeah, I don't know if it matters that this stuff is out of the loop, because I'm using the same one, but I think it doesn't. Like this creates the list, or the list with all the combinations of the two cards, and then a loop of them join to create this string, and then I update the dictionary based on that string. I think that it doesn't matter to do this deep copy here. That's the problem. It should be the other way around, I think, where I change this. Yeah, but then it doesn't matter because it's gonna be updating the same values as well. That's the problem. I was gonna do the deep copy here after, and then send the deep copy. Or maybe if I do it like this. Yeah, but not sure. And then append the new range. As I can just try, just see what happens. It probably didn't work. And it's gonna be the same problem. So maybe it is the combos here that I have to do inside of the loop as well. Or I could just remove this line, because it thinks it's already on the hand range there. Let's try this out. And then I don't need this deep copy. And it's still empty. I think the problem is the whole memory thing. But it's hard to think about a solution. Well, let's see if it works. Yeah, there we go. I think it works now. So the issue was that I wasn't renewing the combinations at each loop. I still don't know what's the best pattern though for this kind of stuff. It's kind of hard to find things about this as well, because I only understood this when I did the whole thing on Rust, because Rust gives you warnings when you do stuff like this, of sending some data structure to an array outside of a loop, or when you do like things initialize like this, and then here you do like this as well. You do a bunch of stuff in the middle here, and then you initialize again. That kind of stuff. Like in Python, I remember a lot of times I could do that, where I use a list to do this. Now it's giving me a warning, but yeah. But I remember using this with lists, and it is not good. And also I think that's even this thing that I'm doing here now, it isn't very good of appending this, because from the memory perspective, it get reads of the structure after the loop. So if you by the time you want to use this list here, the object itself is not in memory anymore because of the garbage collector, I think. Because at the moment you append, it throws away, let's say. So what this is where you would use like something like a pointer, I think, or a reference, something like that. So that's, I'm not sure if that's the right way to put it, but it kind of creates a reference in memory to the object, so that object. But then the issue is that if you send the reference, you're changing the original object. But I think that's what you wanna do on a lot of cases, because later on when you're gonna do stuff with this, it's like you're just moving this thing here to inside of here. But because it's a pointer, it understands that when you want to manipulate stuff here, it's going to go all the way back to this thing here, and then it's going to do the operations. Now let me see if I just append this is going to work as well. It's going to be false. And I think it is working because there is all. So I'm just going to do it like this because I don't care now. But it's weird that it's 0 here on a lot of them. And some of them don't have values. Oh no, they are just on the other column, I think. So it's not really 0, it's just a random number just because of the format here. Yeah, so what I'm gonna do is just loop over this array here, and then I'm gonna save the files. Yeah, I think I have to dump into JSON. The other one I did with the string though. But I think if I do it like this, probably works. Let's see if it works. Oh, it's reads, so it should be writes. Oh, such file. It's weird because I know that it's supposed to. It worked on the other script where you just created the files. even though the path doesn't exist. I think it is in the ranges one. So why is not working now? Maybe it's because I'm trying to use JSON to write to the text file. So like if I want to write it in the text file format, I need to change the data to a string. I could just use the string. Now let's try that. It still doesn't work. It's right, it's right. If I put it like this. Yeah, maybe that's the problem. No, it still doesn't work. Because the thing is that it is working on this script and the files didn't exist before. So it just creates the files. The folders existed, but the files didn't. File name. So this is why I think like it's probably an issue with the folder, but it is the same name there. That's what I don't understand. Maybe it's the directory that is running from. But it should be the same thing, like, because this is assuming the same level of directory there. Or maybe it has to be a string here. That's the thing. I can put a number, yeah. That's a problem. I think I can do this, maybe. Yeah, but it's just gonna put a bunch of different ones. Maybe this works. Nice task. It doesn't matter. Let me just put a name, random name here to see if that's the issue. No, it still says that the file doesn't exist. Yeah, I don't get it. Why it's not working? Well, let me see if I use, yeah, I'm using right as well. Right. The only explanation is the data here, data structure. If I do it like this, I think it's not gonna work, but I think it's worth trying. It doesn't work. Because it's complaining about the name. Very weird. Oh, also I don't wanna write the dictionary. Now I just realized. I wanna write this string. That's the problem. So what I have to do is actually loop over the thing. Because the format has to be in the string. So and then it has to be here. Which is the same thing that I did here. Oh, I used this as well instead. And then I just write this. So I'm looping over the keys and values, and then I'm adding them to the string. Then I remove the last comma, and then I write through the file. But maybe it's not gonna work because the problem is this thing here. But I just don't understand if that's the case because the other script works even though the files didn't exist. Yeah, same problem. What am I missing here? Tax. Obviously, the easy thing that I could do is just create the files manually, but I wanna fix this obviously so I can create a bunch of different files if I want to. Yeah, that's the point. Uh, Let me try this and see if like this will work. It might be because of the way that it's running the script here. Matrix. But that wouldn't make sense because it's on the same level of the other script. Maybe if I put a init file here, it would work. Yeah, there we go. Now it works. But it doesn't create any files. So it's running from a different directory. I don't know why though. And now I have to find these files. I think I can print the directory there. Or maybe it's on the virtual environment. No. Yeah, this doesn't make any sense to me. I don't know what's going on. The other one works fine, but on this file it doesn't. I think there's a dunder method to know which directory the file is, but so I think what's happening is that it's running the file, like it should be running from this file though, which is on this level, which has the thing, but because now it doesn't give me any errors, it saved this file somewhere, but because they are not on this directory, it means that It's like Pio is running them from somewhere else. And I don't understand why. I think it's Deer, the name. Like this. But it should be from some. So maybe Pio, not Deer. Yeah. Mm. It just shows in memory, but not in the. I think a path library has something like that. Let's see. And analysis point. Yeah, which is this folder here. I don't know what's going on. I think I'm gonna stop here then and try to figure this out off stream. But what I'm gonna do next is just, once I save these files with the random dictionaries that I created here, then I'm gonna open them here. I'm gonna manually copy them from where I'm saving them to here. And then I'm gonna open each one and I'm gonna copy based on this file solver format. And then I'm gonna put them, I'm gonna make the connection between the dictionary and the numbers. And I'm gonna try to create an algorithm that figures out the connection between them. Like based on all of the data that I have, which is the correct sequence of numbers for each combo. So that way I can have an algorithm that I guess the dictionary as input and outputs the sequence with the correct float numbers. And once I have that, then I can do. And then I focus on the hardest part, which is thinking about the algorithm of the node IDs and how to create the structure of ranges, so I can node lock the. So I can build the simulations and then node lock them. I think I was thinking about as well that the frequency depends on the lines, obviously. The frequency of each action on each hand depends on each line, so maybe I have to create something like that as well. That when I'm looping to get the data, I create a dictionary or something like that that associates the hand with the action that the player takes. And then I can construct the frequency of actions based on the range. So there's two key things here. One is to get the pocket cards to construct the range, and the other is to get the action that it was taking with the hand. So I need to figure out how to make this connection between each hand and the actions that people took with that hand. But my concern is that I'm not gonna have enough data here to do that. But I think that's the key then, because then I use the frequency, like I use the ranges to build the simulation, and then the frequency should node lock them. I think that's what I'm gonna end up doing. And then once I node lock, then I solve again, and then I use the commands there from the documentation to save the tree. And I think for now, I'm going to try to save them on the river. So get the ranges from the river along with the cards of the river and build the simulation from the river using the range that I get there with and the range that they get there with. And then I'm going to node lock the simulation based on the frequency of each action that they take and get the solution of what is the optimal for my actions, and then save the simulation like that. Then once I save the simulation, then I consider that the whole thing is done, what I wanted to do, because then once you have the simulations, you can just load them to train here with the GTO trainer. But obviously, I'm not going to stop there if I make that happen, because what I'm probably going to do is, I think I'm definitely going to at least parse the other hand format where I have the whole cards, and on that one I think is going to be more interesting. So this one I might even stop after I figure out how to build this, because it might not be worth it to build the... I do want to build at least one, because I'm curious to see how it's gonna look like when I want to have at least some things that I can, some simulations here that I can start training with to get a sense of for what it's gonna be like once I have. So I might end up doing because of that. So I at least have something, but I want to focus more on the style of data that is going to allow me to have the whole cards, because that is obviously going to be better to analyze everything. And then it might change everything because of the data. I think it's going to be a lot easier as well, because the way that the data is formatted on the initial hand there is going to allow me to make a much simpler data structure later to create everything else. So I think it's going to be a lot easier and more effective. So, but this here is super weird. I don't know what's going on, because it is supposed to be working there. So I think I'm going to have to search a bunch of things, and I might still be stuck with this until tomorrow. But yeah, so I think I might do tomorrow I'm gonna leave it for tomorrow for creating the algorithm, because I think it's gonna be interesting, yeah, and it's gonna be challenging as well to think about how to, because it's different than everything else that I've done. It's kind of like hacking, where you have like an input and you have the output, and then the function is a black box, and then you have to figure out what's going on in the middle. So it's very interesting, and I never did something like this, so I think it's going to be kind of challenging. So I'm probably going to do that on stream tomorrow, and I'm going to stop here and try to figure this out with ChatGPT. So I'll probably come back tomorrow, and then if not for whatever reason, then almost certainly 2 days from now